Hello, my name is Jonathan. I am currently a final year student of Roseman University. I am currently looking for a residency that specializes in trauma, emergency medicine, or critical care, and today I'll be presenting my research on C. elegans. I decided to use C. elegans as a model for experimental research in testing dopamine agonists for Parkinson's disease. Now, Parkinson's disease in humans is characterized by the disorder of low dopamine that is typically seen in mid to late age, 50 and above. Due to the fact that dopamine is a neurotransmitter that's involved in movement, having lower amounts of this can lead to various disorders that can be very substantial for later in life. For example, bradycardia dyskinesia, the inability to maintain proper conversational tone and just maintenance, along with behavioral and mental issues that can occur thereof. Tremors can occur along with gait, considering the fact that older people do have various weaker bones due to osteoporosis. This is of a concern for that reason. This is why common treatment for decreasing development of Parkinson's disease has been the usage of dopamine supplementation, carbidopa and levodopa to be exact. However, I decided that it was important to look at second line options, for example, these dopamine agonists, just because not a lot of research has been done into them on their overall effectiveness in that of human beings. Now, in the brain, dopamine is controlled by these receptors called G-coupled receptor kinases, and also known as GRKs. GRKs are the receptors that are accepting of the dopamine when the dopamine first hits the receptors, and is able to maintain and regulate the nervous system as it stands. There are three different subcategories of them in humans, known as GRK1, GRK2, and GRK3. More specifically, there are 5 different kinds. However, I decided to go like subcategories just because of the fact that it's far more easy to generalize them when comparing them to that of C. elegans. Now, you might be wondering, why would I use these roundworms? Why would I use, of all creatures that I could use to study this, why these lowbacks? And now the answer is because of not only genetic similarity, but also because of the receptor likeness to that of human beings. As seen right here, 41 to 59% of the C. elegans genetic material is of genetic similarity to that of humans. Therefore, considering the fact that they are much, much more simple in comparison to that of human DNA, I decided they would be a perfect subject of research for that reason. Same with, though Drosophila fruit flies do have similar genetic similarity, I discovered that the GRK1s and 2s also were very, very human-like in comparison to that of when studying that of the Drosophila fruit flies. Drosophila not having as human-like with the two subtypes in C. elegans being GRK1 and GRK2, I wanted to study into this further to use them as a model to see dopamine agonist effectiveness in that of them, crossing it over to humans. Now, as doing my study, I decided to compare the egg-laying behavior of the C. elegans when they're treated with the different dopamine agonists, pergolide, bromocriptine, and cabergoline. Just because when looking at the C. elegans, their egg-laying behavior is greatly correlated with that of the dopamine levels in the body, declaring that the more eggs that are laid, the more the dopamine receptors are being activated, thereby showing that this medication would be working more substantially or less substantially depending on that number. Then for materials and methods, I had chosen 3-day-old C. elegans, the youngest of which they would reach maturation to be laying eggs, with the different concentrations of pergolide, bromocriptine, and cabergoline. The dopamine receptor activation, as stated previously, measured by eggs laid. When I was studying them under the microscope, I was using an optimal microscope and I was counting the eggs in the larvae after 1 hour and 24 hours respectively. Now in research, it was very interesting to note when I would see the trends that would occur in 1 hour compared to 1 day respectively. Pergolide being known for the GRK1 and GRK2 acting medication, it was interesting to note that on the first hour it seemed to have a gradual incline despite the GRK1 and GRK2 lacking. However, when seeing the after 1 day, that it would seem to reach a concentration and then it would taper off after that, for all of the wild-type GRK1 and GRK2 lacking, respectively. Then for bromocriptine, knowing that bromocriptine is mostly acting on the GRK1 receptor, it was interesting to note how, for the wild-type on both ends, it would more or less have an incline to have a peak concentration, if you may, and then taper off after that. Then for GRK1s, it seemed to have, as one day would go on, the one that lacked the most of the medication would have the highest egg-laying rates compared to that of the other ones, which had lower egg-laying rates. And then for GRK2s, having different inverse effect of that of increasing in concentration during the first hour, but then just having a maximal concentration at the lowest concentration, and then just decreasing after that. Then cabergoline, it was interesting to see how this medication is more of a GRK2 acting. The fact that the GRK2s were not as effective per se as the GRK1s were, which conceptually makes sense, I suppose, considering that the mechanism of action of the medication is to do such. While types seemed more consistent, definitely, just among all the egg-laying rates, and then the GRK1 would incline and then have more of a increase in taper off when comparing the 1 day to that of the 1 hour. While looking at GRK2s, it just seemed to increase the entire time as seen fit. And then, as stated previously, the research trends were shown to be overall effective. There was something happening, thereby showing that these medications do work in their own given areas. Now, for future directions, one of the things that I'd like to see with this research is being able to study this more consecutively, just because I only had 6 weeks in order to compile the data of which I have currently as it stands. I would like to see longer projects just doing this on a greater and wider scale, just because knowing these medications and the mechanisms of action, I would like to know just how more specifically it's affected in greater trends over a longer course of time. Along with how I'd like to see more of the dopamine agonists just being tested in general, just because this was only 3 medications. There are currently 7 medications that are widely available on the market, and if we were able to test more of them, we could have a greater general picture of dopamine agonist effectiveness for treating people with this disorder, so that way we could be able to have greater options rather than what we currently do have right now. I would also like to, the final thing would be to do age comparison studies, just because the C. elegans, knowing its lifespan being 4 to 6 weeks, and then these roundworms being tested on the 3rd day, I would like to just see how it affects them when put in relation to that of human beings. For example, testing these worms on their 2nd or 3rd week of life when seeing humans that are more affected in mid to late life in terms of how the disease affects them. And then that's all that I have for today. If you have any questions, please feel free to contact me, as stated from the link that you have stated or has been sent to you, and have a wonderful day.